so quick little mini hit unit. So Math 2, which is going to be the class that you go to next. Math 2 was saying that there was some issues in that class with perimeters and areas. So we're going to give you a quick hitter of a refresh on perimeters and areas today and tomorrow. And then we will, just seeing it again, hopefully will get you back ready to go for next year for perimeters and areas. Okay? All right? So, in the basics of basics, what does perimeter mean? So how do I find it? You're right. Okay? It's the distance around the outside. Around the outside. How do I find it? Add up all the sides. So perimeter goes with addition. Okay? All right? Write that down. Perimeter, addition. Okay? One and the same. Perimeter goes with addition. Okay? Area. What's the area of a shape? The space inside, right? Okay? And that depends on what kind of a shape it is as to how we find it. Okay? Most of the time, it's going to be a rectangle. Okay? Or we can do it length times width. Okay? If it's a triangle, then it's 1/2 length times width. Okay? But we'll get to all those a little later on. Okay? So areas of triangles and composite shapes. Okay? How much grass would it take to cover a football field? How much paint would it take to cover a stop sign? Okay? So on and so forth. Okay? So those are all different size shapes. Okay? So if you'll notice here on these first, is there 6 of them? The first 6. Okay? So we need to find the area of the figure. It's asking just for area. It helps to know what we're doing because that's going to tell us if we're multiplying or if we're adding, right? Perimeter goes with adding. Area goes with multiplication, okay? All right? So perimeters with adding, areas with addition. Oops, I said that wrong. Perimeters with adding, areas with multiplication. So if we need to do area, that means that we're going to be multiplying something. We're not going to be adding up all of the outsides. Okay? Now here in letter A, that's what's called a composite figure. It's made up of 2 or more different figures. Depending upon how you want to break it up, you could break it up into 2 rectangles. Okay? So we need the length and the width of each one. If this entire green side here is 11, this blue length here is 8, which means that this blue length down there would be also how much? 8. So that would be 8 there. So now I've got a length and a width for that rectangle. If that blue length down here is 8, what is this red length right there? 3, right? Because it's 11 all the way. So that's 3 there. So that's my width. There's my length. So now we can find length times width is the area of a rectangle. So this total area here is going to be the area of this red one, 5 times 3, plus the area of the blue one. The blue one is 8 times 3. 5 times 3 is 15. 8 times 3 is 24. 15 plus 24 is how much? I thought you just said 30 there for a second. Okay. Right? So 39. So the area here is 39. Anybody know what that symbol is that's going on for that one? What does that symbol mean on those dimensions? Anybody know? Anybody? Single slash? Anybody know? People in construction have ever? It is feet. Yep. 2 slashes is inches. 1 slash is feet. So this would be in square feet because area has a squared label because we're multiplying. Okay. Is the label important? Yes. If there's a label in your problem, there needs to be a label in your hand. Okay. You at your table find me the other 5 areas. Go. On B, I want the area of the shaded part. For letter B, I get 256 square meters. Area of the shaded region is going to be area, the big region minus the area that we took out. So big minus small. Yes? Okay. Right? Anybody go any further with it? Or do we leave it like that? Can we leave it like that? Length times width, right? Can we leave it like that? Yeah, we can. If you decided to go further with it, it would be that. Okay? But either one of those would be acceptable. Yeah? So these marks say that they're equal, so those are all 3 are equal, so that means that they are all then 9, because it's 27 all the way across. These 3 are also equal, that means that they are all 6, because it's 18 across, or up and down, I should say. So this would be in here in my pink rectangle number 1, that would be 6 times 9, or 54 square centimeters. In my green rectangle here, that would be 9 times 12. 9 times 12 is 108. And in my purple rectangle here, that would be 9 times 18, which is going to be 162. Add them all up, and we get 324. 6, 10, yep, 324. Questions on any of those three so far? Yep. How much of the rectangle do we have? Half of it? So we get 35 square yards there. Yep. If this part is 4, this part is 10, what's the whole thing? 14. That's the base. So the area of a triangle is going to be 1/2 base times height. The kicker is that height has to be perpendicular to the base. Okay? That's how you know that it is the height. It is perpendicular to the base. So then this is going to be 1/2 times 14 times 5, which is going to be 7 times 5, which is going to be 35 square inches. 2 dashes like that in F is inches. 1 dash like that in A is feet. Huh? All right. Area of a triangle we've talked about already, so we're good there. How do we know which dimensions to use when finding a triangle? We have to use perpendicular. So we would use, in this particular one, we would use 14, and we would use 3. 14 would be the base. 3 would be the height. In number 2, what would be the base? Which of those dimensions is the base? Quit it. 5.9 is the base. You are correct. If 5.9 is the base, which is the height? 6.8 is the height. Yep. Because it's perpendicular. Okay. Which of those dimensions in number 3 is the base? 8 is not part of the triangle. So which one is the base? What do you mean both? It can only be one. It can only be one number as the base. 6 is the base, because it's the part of the triangle. Okay. If 6 is the base, what is the height? 5 is the height, because it's perpendicular to the base. Okay. Gotta have that relationship. Bases and heights have to be perpendicular. Write that down. Bases and heights have to be perpendicular. Okay? So if they're not perpendicular, they are not bases and heights. You can't use those two dimensions. You don't just get to willy-nilly use any two dimensions that you want. Okay? In a triangle, you've got to use the two that are perpendicular. And in list number 3, I'll outline it here in purple. Okay? Here is the actual triangle. So when whoever said 8 first, 8 is not part of the triangle. So it's got to be a part of the triangle. Okay? Love it. Let's switch over to perimeters. Okay? So now same figures that we had before, okay? But perimeters, what's the word that goes with perimeter? Addition. So we have to find all of the sides first, then we can add them all up. Okay? So I know that this side is 5. I know that this side is 11. I know that this side is 3. I know this side is 8. Ruh-roh, I need this blue side right here, and I need this pink side right here in order to complete my walk around the outside. What is the length of the blue side? It is not 5. Why is it 2? So if I were to extend this out here, this part would still be 3, right? Which leaves me with this part being 2. So my blue dimension here is 2. Okay. What is my pink dimension? 3, because if I were to extend now this way, this part would be 8, this part would be 3, so the pink part up here is 3. With me? Okay. So now to find the perimeter, I start at one spot and I go all the way around. I should have 5, then 11, then 3, then 8, then 2, then 3. So then I add all of those together. 16 plus 3 is 19. 19 plus 8 is 27. 27 plus 5 is 32 feet. Perimeter is a singleton label. What? All right. Area, the label is squared. Perimeter, not squared. Okay. All right. Find me now at your tables the perimeter of the other. Do we have all 6 or just 4? Of the other 4. Go for it. Or the other 3. There's only 4 there. What's the blue length that we're missing? 12. What's the green length that we're missing? What's the purple length that we're missing? And what's the pink length that we're missing? 8. Do I need to do both of those perimeters for this shape? Yay or nay? We have to add up all 8 of those boxed dimensions. Perimeter is anything that touches the outside, right? Okay. So anything that touches air, right? If we think about it as a shape, that's a hole in the middle, so that's part of our perimeter. Okay? Right? Think about it as if you had to put a fence up around your yard. Okay? You have to put a fence up around that middle part too, if there's like a big hole there, right? So nobody fell in the hole. Okay? So my perimeter here is going to be 12 plus 24 plus 12 plus 24 plus 8 plus 4 plus 8 plus 4. 36, 72, 80, 92, 96. 12, 24, 48, 72, 96. Yep, 96 meters. Yep. What's the blue missing dimension? Two x plus 3. What's the green missing dimension? X plus 4. How many x's do I have? 6 of them. 3 plus 4 is 7, plus 3 is 10, plus 4 is 14. I get a perimeter there of 6x plus 14. In this figure before, we said that these were 9 because they're equal and divides into there. In this figure before, we said these were 6. So my perimeter here is going to be 6 plus 27 plus 18 plus 9 plus 6 plus 9 plus 6 plus 9. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Yep, got them all. Let's see. 6 plus 27 is 33, 43, 51, 60, 90. 15 is 30, 39, 49, 58, no. 15, 30, 39, 49. 57, 63, 90. Quickly going over your homework. What do I know about a triangle? This is review. If I've got measures of triangles, what do I know about the total angle of all the angles of a triangle? It's what? 180, so all 3 angles add up to be 180? Yep, exactly. Okay, so all 3 angles add up to be 180. We can find them from that. That is review. That is not new. Everything in this is review. Okay.
Rotations. Oh, I love it. This is good finals review too. Rotations on the homework. I love it. Perpendicularness. Love it. Find the shaded area. Love it. Angle relationships. Love it even more. Find the area and the perimeter of the figures below. Love it even more. Okay? All good stuff that can be done